All right, so today we're going to finish up chapter 8. The lesson is on determining whether a linear, exponential, or quadratic function best models a data set, and looking at different ways of modeling data, whether it's graphing or a table of values or a symbolic representation. We usually call it a function. And we'll look at all of those as we go through today. All right. So here is our first example. If we have a linear function, and we've worked with those, and you've probably worked with those more than anything else in your mathematical careers. A linear function is a function that is graphed as a straight line, which to me is a little bit redundant. All lines are straight, but it is a straight line, and it has a constant rate of change. You see a graph. That is the graph of the equation y equals 2x plus 1. So linear functions, generally there are two ways that they are written, or two common ways they are written. Everyone's favorite, y equals mx plus b, or sometimes it's written as ax plus by equals c. But a couple of things to notice: we have both an x and a y. It could be f of x equals mx plus b as well, but they're both to the first power. That's going to be a big difference as we look at the other two models. All right, if we look at a table of values, if I plug -1 into my equation, 2 times -1 is -2, plus 1 is -1. If I plug in 0, 2 times 0 is 0, plus 1 is +1. Plugging in 1, 2 times 1 is 2, plus 1 is 3. And if I plug in 2, 2 times 2 is 4, plus 1 is 5. One way to look at a table of values and tell if you have a linear function is by subtracting consecutive values of y. So if I take 1 minus -1, so I'm always going to take the second one minus the first one, or the bottom, the lower minus the upper. So 1 minus -1, that's 2. 3 minus 1 is 2. 5 minus 3 is 2. This is called the first difference. And if the first difference is the same, we have a linear function. As a matter of fact, if you look, the first difference is the same as the slope. All right. So one example, Allie has $20 and she can make $5 per hour babysitting her sister. How long does she have to babysit to have $50? So here is our constant rate of change. The amount she earns goes up by $5 every hour. Right. Questions with linear. Again, I think maybe the easiest to see. The next couple are a little more difficult. So this next is quadratic functions, and we've been dealing with those pretty much for this trimester. So again, hopefully you're pretty familiar and comfortable with them. Definition: a function that is graphed as a parabola, and it shows increase and decrease in one variable. So you can see in the graph, as I go from left to right, the graph goes down, there's a decrease, and then it goes back up. There's the increase. Again, there are several different ways that you can write an equation for a quadratic function. We have our standard form, which is the one given here, x squared minus 2x plus 3. We have vertex form. We could have y equals a x minus h squared plus k. Or we could have intercept form, the one we talked about right at the beginning after spring break. And that would be y equals a x minus p x minus q. That's intercept form. Most often you're going to see quadratics in standard form. It just is the most common way to write it. So if we look at a table of values, the way we can tell if we have quadratic form, we'll take a look here in a minute. First, I'm going to plug my values in, and I'm not going to write it out. I won't have enough room. But if I plug -1 in, I get -1 squared, which is +1. -2 times -1 is +2, and then -3. So I have 1 plus 2 is 3 minus 3 is 0. And you can see at -1, 0 on the graph. When I plug in 0, I know I'm going to get my value for C, my y-intercept, -3. If I plug +1 in, again, if I look at my graph, I get a -4. And we can look at that. It's 1 squared, which is 1, minus 2 times 1. So 1 minus 2 is -1, minus another 3 is -4. And if I plug 2 in, I get 2 squared, which is 4, minus 2 times 2, which is 4. So 4 minus 4, 0, and 0 minus 3 is -3. So for linear functions, if we subtracted consecutive values, we got the same exact difference every time. For quadratics, if I subtract consecutive y values, -3 minus 0 is -3. -4 minus -3 is -1. -3 minus -4 is +1. Not the same difference. But if we look at our second difference, -1 minus -3 is 2. 1 minus -1 is 2. So the second differences are the same. Another way to tell on a table of values, other than the differences, look for some symmetry in the values, right? Then we have a -3 on both sides. I think in this case, the graph probably shows it the easiest to recognize. A situation that would be modeled by a quadratic function. John throws a baseball up in the air and wonders how high the baseball reaches. So that's one of our problems like we did last week. We called them vertical motion. Could also have those area problems like we had last week, area of a rectangle. So that's quadratic. The third type we're going to talk about are exponential, and these may be real new, which is okay. Let's look at the graph. First of all, notice this graph is very close. It actually isn't touching the x-axis, but it's very close for negative values. And then as we get to 0 and positive values, it really grows fast. So one way to describe or define an exponential function is a function that is graphed as a partially curved line that shows a very fast increase or decay in one variable. This one shows increase. If it was going to show decay, it would be just the mirror image. It would go this way. That would be decay because it's decreasing. An exponential function has x as the exponent. So the general form is just y equals a times b to the x. And sometimes it will be written with b to the x in parentheses. I like the parentheses because that reminds me that the b is the only thing to the power of x. So a table of values, in this case, if we plug in -1, 2 to the -1 is 1/2. 2 to the power of 0 is 1. 2 to the power of 1 is 2. 2 to the power of 2 is 4. The pattern here is not a difference pattern. You won't be able to take and subtract and get the pattern to be the same number every time. The pattern here is actually multiplication. To go from 1/2 to 1, we multiply by 2. To go from 1 to 2, we multiply by 2. To go from 2 to 4, we multiply by 2. So if you're looking at a table of values and wondering if it's linear, quadratic, or exponential, if you do the differences, the first and second differences, and you don't get the same value for either of those, then it's a pretty good idea or a pretty good guess that you have an exponential function. So one situation, the change in population often is described as exponential. Okay. Other situations, anything that doubles, triples, quadruples, etc., would be described as an exponential function and would show exponential growth. We could also have things, anything that goes half or a third or a fourth, like that would be exponential. It would just be exponential decay. Anything that shows an increase or decrease of a certain percent over time. That would be exponential. And then we did talk about populations. Those would be exponential. All right. Questions so far? I would say mark that page in your, or those 2 pages in your packet if you have it. If you're doing notes in a notebook, mark those pages so that you can refer to them, get to them quickly, so that as you're taking a test or a quiz, you have that information right at your fingertips. All right. So what we're going to do is look at these 3 functions and or equations and tell whether they are linear, exponential, or quadratic. So if I look at x squared minus 5x plus 6, is that going to be linear, exponential, or quadratic? Go ahead and put it in the chat, but let's make it easy. Let's go L for linear, E for exponential, Q for quadratic. All right, so we have some agreement in the chat. We're thinking that this is quadratic, and I would agree. Quadratic. How about 3x plus 3 moving across there? Linear, exponential, or quadratic? All right, a few more participants. Excellent. I like it, and I agree. They are in agreement. That is linear. Yeah, excellent. Wow, great. All right, and how about the third one here? Y equals -2 times 4 to the power of x. Someone was already beating me to it. All right, I like it. Yeah, terrific. Now be careful, all right? I know there were 3 choices. Don't just say, well, the first one was quadratic, the next one was linear, the last one has to be exponential. But make sure it is exponential before you just say it is. And this one is, it has x in the exponent, so we're good to go. All right, so that's looking at the equation or the function. We could also classify them by looking at the graph. So again, I think we're going to go L for linear, E for exponential, Q for quadratic. I need to move my chat out of the way, maybe. Maybe not. Hard to read it if I can't see it. All right. So yeah, what about this first one? What do we think? Yeah, yep, good, looking good. Looking good. Oh, First one, definitely linear. We got someone already posted what they think all three of them are. That's great. What about the second one? Quadratic, I would agree. And our third example. Exponential, I like it. All right. Now we're going to look at a table of values. And again, I would look at those first, second, and third differences or other things in the table. If we look at the first difference, 0 minus 1 is negative 1. 1 minus 0 is 1. 4 minus 1 is 3. So the first difference is not the same. It's not linear. 1 minus negative 1 is 2. 3 minus 1 is 2. So what do we think? Linear, exponential, or quadratic? Yeah, that second difference is quadratic. Or I should say when the second difference is the same, the function is quadratic. All right. What about this one? What do you think? Again, if you're not sure, take a look at the differences. Got a lot of agreement in the chat. I love it. 3 minus 1 is 2. 5 minus 3 is 2. 7 minus 5 is 2. So the first differences are the same. That would be linear. You could also, if you had graph paper, you could graph it and just see, does it graph like a line or a U or that curved shape? That would be a possibility as well. All right, third one. See if I can get anyone here. If we look at first difference, 1 minus a half is a half. 2 minus 1 is 1. 4 minus 2 is 2. If I look at the second difference, 1 minus a half is a half. 2 minus 1 is 1. So the second difference is not the same, so it's not quadratic. But one thing to notice how the first value in the first difference and the second difference are the same. The second value in the first and second differences are the same. Kind of interesting. So if the first and second differences are not the same, hopefully we're thinking, well, maybe exponential, but then we have to determine what do we multiply by for it to be exponential. And I think it's easy to see right here, whoops, right here, we multiply by 2. And right here, we multiply by 2. Maybe a little more difficult to see it with the fraction, but this one is exponential. All right, so here are 3 different situations. The number of rabbits living in a state park, the total children enrolled in a beginner's karate class for 4 consecutive years. If every year 3 more people join the class. And finally, a mechanic throws a wrench from the top of the building. What is the path, or how would you find the height of the wrench? So go ahead and give me all 3 of them. So let's call this one number 1, call this one number 2, call this one number 3, and just separate them by parentheses in the chat. What do you think? So if you think it's linear, then exponential, then quadratic, just type in LEQ. If you think it's something different, type in, but type in the 3 letters for 1, 2, and 3. All right, getting some answers in. This is excellent. So population, we said most often is going to be exponential. Here, the key here is 3 more people every year. 3 more people join. That's a constant rate of change. That would be linear. Throwing a wrench, that's our vertical motion. So this one is quadratic. Okay. So I know there were some that thought maybe the first one was quadratic. If it was quadratic, then the population would grow and reach a maximum and then decline. And usually with population, that doesn't happen. Now, it could, based on things like hunting or other things, but we're not going to put those other situations into our problem. All right. So here you have a whole list, 10 different descriptions, graphs, tables, equations, all sorts of things. What I would like you to do is take a couple of minutes, do your best to figure out, are they linear, quadratic, or exponential? Don't put these in the chat, all right, just because it would be too difficult to figure out which one is which. But then we'll take a look at the answers here in about 3 minutes. So I will set a timer for 3 minutes. I'll make sure it's out of the way. And then I will stop talking and let you go ahead and work. All right. So let's take a look. This upper left-hand corner is exponential. Temperature of a preheating oven increases by 50 degrees each minute. There's our constant rate of change. Linear. Table, so I'm going to look at differences. And my second difference is the same. Quadratic. Here we have one kind of a new situation. It depreciates or decreases by 12% per year. And in our definitions, we said if it decreases by 1% over time, that was exponential. Because, the first year it goes down 12% of 20,000. The second year it goes down 12% of whatever it was valued at after the first year. So it's a little bit different amount each time. X squared, so quadratic. The path of a basketball when a player shoots a free throw, that's a vertical motion. Excuse me. So quadratic. There's our graph increasing very quickly. Exponential. There's our upside down parabola. I'll write it underneath. Whoops. Quadratic. Here, if I look at first differences, -10, -5, -2.5. 5, 2.5. So the first and second differences are not the same. So we would not choose linear or quadratic. And I notice I'm taking half each time. I'm multiplying by 1/2 or 0.5. So exponential. Okay. Another way to tell, or another hint that it might be exponential, is if we have all whole numbers and one fraction or decimal. Usually that's exponential. Could be quadratic, but usually not. This one, 5 minus -2 is 7. 12 minus 5 is 7. 19 minus 12 is 7. First differences are the same. Linear. All right. Questions? All right. Well, the homework and the note check are already posted. I will set up our breakout rooms, and we'll meet there and we can talk. If you have questions, you can ask there as well.